We've spent quite a bit of time on the idea of tables and arrays, so let's quickly work through some syntax. As you can see here, there's multiple ways to define the array. One of the most formal way of doing it is here explicitly. And so what you can see is that we have, right, C equals curly bracket. By the way, curly bracket is called the table constructor. That's how we build the table. Also, for those of you who are really keen to understand some deep Lua here, C is a variable name, but it is a pointer at the table. It is not the table itself, but it's going to be okay.
Can we just take a moment to respect the fact that the man who calls a hashtag an octothorpe is calling this a squiggly brackets? Just want to throw that out there. We're still using squiggly brackets and not their official names. I'm sorry, continue.
I don't know everything, Nate. What do we call them?
The brace.
Sure. The squiggly brackets, as I was saying, they're just going to be squiggly brackets. So C equals squiggly bracket, that gets us a table, and then bracket 1 equals R, bracket 2 equals string G, bracket 3 equals string B. That is really wordy, okay? But we can then index the table by saying C square bracket 1, and right, you stick in the 1, you pull out the R, all right? This is the explicit construction of the table. This is perfectly valid, perfectly fine. It's like the full formal syntax, and it sucks. So implicit construction, as you can see, sucks less. C equals squiggly bracket, R comma G comma B is a lot easier to write. This is a much friendlier shorthand way of constructing the array. Lua is assuming that you are associating key number 1 with string R, key number 2 with string G, and key number 3 with string B. And similarly, if you index that array at key 1, you get the string R. Here's another example. Days equals Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. If you index days at number 4, you will get the string Wednesday. Now, when we think about arrays, we want to think about how do I use the arrays and why do I do this at all anyway? Let's work through another simple example. The simplest possible array is key number 1 being corresponding with value number 1, key number 2 associated with value number 2, and etc. And so here at the top of the page, we have the table A. A equals squiggly bracket, curly bracket, brace. Whatever it is you like to call it. Fine. Brace. A equals brace. Here's a for loop. Never seen a for loop before, Jeff. Well, now you're seeing one. You're going to pick it up real quick. For I equals 1, 10, do the following. Basically, what's happening here is we are going to iterate through the array. We have in Lua created a for loop that automatically creates an iterator local variable named I. It could have been J or K or Nate or whatever you wanted it to be, but it's I in this case. It's starting at the number 1, it's going to the number 10, and it is assuming that it's going to count by 1s. If you wanted it to count by 2s, then you would have said for I equals 1, 10, 2, and then it would count by 2s. But that also makes you a monster, and so don't do that. The point is we have a for loop. For I equals 1, 10, counting by 1s, do the following. We are going to populate the array at key number 1 with the value number 1, key number 2 with the value number 2, key number 3 with the value number 3, all the way to 10. Fine, easy peasy. We now have an array. It has 10 things in it. now let's start to do something interesting with it. And when I say something interesting, what I mean is plant the seed of something that will become interesting, because we're just going to print them out. And that's not super interesting at the moment, but it will grow into something that is actually very interesting.
I think that's actually the theme of this entire video. Is it's not interesting yet, but we're planting the seeds of something that will become interesting later on. Go on.
Thanks, Nate, I guess. Anyway, let's traverse the table and print it out. So this is another one of these places where we are going to wind up doing something that is abstract but exact. So let's look at how we've written this. We wrote a for loop at the top of the page. We've written another for loop at the bottom of the page. At the bottom of the page, we're saying for I equals 1 to, and instead of saying to 10, instead of hard coding 10, we're saying go to pound A, hashtag A, octothorpe A, all the different ways that Nate wants to correct my vocabulary, from 1 to pound A. That is an abstract but an exact way of saying how big the array is. Right? This is a really clever way of saying 10, because we're saying go from 1 to however big you are. And of course, what we would expect is that it's going to run from 1 to 10 and print out 1 to 10. Now, it's actually really important that we learn how to speak in this abstract but exact manner, because think about it. What if we took something out of that array? Well, then it would only run, we would need it to run from 1 to 9. If we had hard-coded to run from 1 to 10, it would have printed out 1, 2, 3, 4, 5, 6, 7, 8, 9, nil. Whoa, nils are like hand grenades sometimes. They can really blow up your code if you're not careful. It's really important. What if we actually added something and now there's 11? If we had hard-coded run from 1 to 10, then we would only print it out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we would have left 1 out there unprocessed, untouched. That wouldn't be good. Now, our example is simple, but as you're going to see through the rest of the course, it's actually really important that we make sure that we get to all of the things inside of our data structures as our data structures grow bigger and smaller as we do things. One last slide, and then we're going to write some more code. Because in Lua, we've seen that for loop, that's called the numerical for loop. But since we're working with arrays and tables, there are two forms of the generic for loop that are relevant to us. The pairs loop is the most powerful for loop in Lua, because it will run through the entirety of the table. It will touch every key value pair. And that's why it's called pairs, because the table is pairs of keys and values. Pairs loop always works. It always works.
Except for the time they tried to add it as one of the flavors in Fruit Loops. The pear flavor was not, it just didn't mix well with the apples, and the lime and stuff. So the pairs loop didn't work in that instance, but it does in code.
Pairs is the most powerful form of the for loop. For arrays, there is a handy generic for loop called the I-pairs loop. And we're going to use I-pairs quite a bit. I-pairs is appropriate for arrays because it, like tables, has key value pairs, but it's going to restrict itself to all of the integer key with value pairs. So integer pairs, right? That's how you get I-pairs. And so let's look at an example. And this is the last one before we dig in, I promise. The table T is equal to 11, comma buffalo, comma 10, comma 12, comma high. And then here's the syntax. For I, comma V in I pairs on the table T, do the following, print I, comma V. Now, what is I? What is V? I is the index key. V is the value. We simplified it. Somebody, when they wrote this thing, they just simply said, you know what? Index, integer key, whatever it is we say there, that's kind of a lot of things. We can get that whole idea by summarizing it down to one letter, I. It gets across the idea we're talking about indices, integers, whatever it is, we're talking about I's. V stands for value. That's it. Now, does it have to be I and V? No, these are local variables to this loop. Could have been key, comma, value. It could have been Nate, comma, Patrick. I really don't think Nate, comma, Nate would work. It would not be happy with that. Now, if you did little Nate and big Nate, that would work out. Anyway, print I, comma, V, and you're going to get exactly what you asked for. I, which is 1, and V, which is 11. 2 and Buffalo, 3 and 10, 4 and 12, 5 and high. Now, I know we just blew through a lot of brain dump on the idea of data structures, but they really are that important. So here's the nickel tour. Tables are key, comma, values. Arrays are special cases of tables. Arrays have integer keys, and that's really the whole story. Let's come back and let's rewrite these 4 event handlers, which took, goodness, 14 lines of code, and let's collapse this into scalable, brief code. We're going to be able to replace the 4 event handlers that took like 14 lines with like 1 loop that takes like 5 lines. So let's turn the corner and let's write some concise, flexible, scalable code. So here we go. For I, comma, CTL in I pairs on which table? On the array called controls.btn preset. And notice how VS Code is prompting you to enter inside of the square brackets. Just get rid of the square brackets because we don't want a particular one of the controls. We want all of them. We want the whole array. And we're going to do something. And the first thing we're going to do is we're going to end that loop. And inside that loop, notice how we already have the CTL there for us. Because what is in that array, right? When we did count 1, 2, 3, 4, we created number 1, it's button 1. Number 2 is button 2. Number 3 is button 3. Number 4 is button 4. I is 1. CTL is the button. That's what we're going to get out of this. And so here we go. CTL.eventHandler is a function. And this is a time where we don't need to pass in CTL again. We already got it. And so what do we want to do inside of our event handler? We're going to print, we're just going to do this. Button number. And we can concatenate in that I. And then we can get rid of these and see that we have replaced from 7 to 21 with from 7 to 11. Now when we hit save, we can see that we now have the same functioning code, but written much, much briefer. I think that's really fun. I think that's really neat. And the reality is this is the beginning of really scalable code.